right? So I was talking about the real world and the virtual world, right? First thing that you have to understand is that one before you use a computer, because in the computer there are things which belongs to the real world as well as there are things belong to the virtual world, right? Okay. So first we have to understand. So therefore, now we are talking about everything that you get in our world, in our real world, right? Are called objects. Are called objects. Human beings are objects. We can classify them into male and female, adults and children. Okay. Then say again classification small or infants, maybe children, maybe adults, maybe elderly people, like that we can classify. So classification means you group them. So when you have a group, you will find there are common properties that the group is having. So it's easy to handle. As I told you, if you find unknown animal, but if you have the experience with the common properties of an animal, you will first think at a glance, you will be scared about the animal because an animal might attack you because they are cruel. So that is the property, right? So it's easy once you classify things, it's easy to handle them, because from the day that we are born, we are interacting with the real world things, right? Now you all are seated, you are listening, which is interaction. Huh? Suppose you are seated on a seat or a chair, right? Which is interaction. Which is interaction. You are interacting with the chair, the object called chair, right? So the chairs belong to the group called furniture. Most of these are, made of wood or steel. So we have a common property there. So to make things easier, real world objects, we find there are billions of real world objects. We classify them into classes. So therefore, in programming, we have a concept called class. What is a class? Right? A class is something that represent classified things in the real world, which is a class. Right. So here, let me read my note here. Classification is the action of grouping things or grouping something, right? The things in the real world or the virtual world, as I told you, can be categorized and put into classes. Real world objects can be classified into living things and non-living things, right? I explained it. Living things can be further classified. Even non-living things can be further classified. Okay, take this scenario, right? You will find, 3 categories of trees, but they belong to the category called tree, right? Trees are grown on the earth, which is one property. Okay, trees bear a trunk, which is another property, right? They produce fruits, another property. So therefore, if you find any other member which belong to the tree class, we can understand what is it easily by by seeing the common properties. That is the advantage, right? Now you will see, take this jack tree. This jackfruit is common to jack trees, one category. Mango tree, right? You will never, find mangoes on a jack tree, or the vice versa. You will never find jackfruit in a mango tree. Likewise, coconut tree. They are different, but commonly they are fruits. They are fruits. Commonly, they are fruits, belonging to fruits, and here they are trees, right? So first we have to understand that, right? So we know that real world things can be further classified. They consist of physical things which are tangible. Tangible means you can touch them. Others are intangible. You can't touch it, but we use it. As I told you, and a transaction that you go to the bank and do. You withdraw some money, right? So you fill a form and give it to them physically, right? Then after that you will get money, but completely we call it a transaction. Although physically things have happened there, but you can't touch the thing called transaction. So we categorize them as virtual things. So therefore, in the real world, we have real things as well as virtual things. We call them objects. We call them objects, right? Okay. How objects are classified in Python? Now, what is Python? Python is a language through which we communicate with the computer, no? Okay. We explained or we learned in the first two lessons. Python is a high level or a computer language that we use to communicate with the computer. I told you why we need to communicate with the computer. We have advantages of this machine. So computers are reliable. Computers are fast, extremely fast. So we can do things in a very short time. It's an advantage when compared with the human being. It has memory. It can remember things, right? So we have a lot of advantages. So therefore, to make use of our computer, we need a language to communicate, right? We need the language to communicate, right? Can you touch the language? No, right? Intangible, no? But we take them as objects because they exist in our world, right? They are not tangible, so we call them virtual objects, right? So computer is having virtual objects as well as physical objects, right? Physical objects are called hardware, virtual objects are called software. Those are the two things that when it comes to computer programming or computing, we use. Right. How objects are classified in Python? I was talking about here how we classify things in the real world. How we classify things in the real world. We classify physical things in the real world, such as, say, maybe oceans, okay, maybe planets, right? Maybe trees, maybe vehicles, okay, and various other categories are there. Maybe children, maybe human beings, maybe animals, birds. All these are classes, right? But when it comes to the computer, right? Now the computer is always interacting with us, no? We are in the real world. We are in the real world, right? Most of our work is with the real world. So the computer, again, without any brain, want to communicate with us. So we use a language called Python or any other computer language to communicate with the computer. This is what we do. This is what we do. So now with the language, what do? You write a code. You write instructions for we write instructions for the computer to obey and execute by using a specific language. This is programming actually. It's a code. It's not a natural language. It's a code. Right. Now let us see how these two things interact in the real world. How these two things interact in the real world. Real world objects as well as the computer. So communication is made through the programming language. Right. So in programming, so as I told you, computer has touchable or tangible objects we call hardware. In addition to that one, we also have untouchable or intangible things. In the computer, we call them software. Can you touch software? No. Okay, intangible. But they are objects. So in programming, what you do really, we use software objects, okay, software objects which are models of the real world objects, which are models of the real world object, right? In the real world, we have enough problems. How these problems are created? Problems are created due to interaction. Okay. For example, say even eating too much is a problem for human beings. So we are interacting with the food and eating many things, which is interaction that creates a problem for us. You become sick, or you become fat, right? They are also problems. Okay, so that is called the interaction. Interaction will create problems, right? Some problems we can solve ourselves. We have a solution. For some problems, we take years and years to solve because our human capabilities are not enough to solve the problem. So that is why we go to the computer to do it very fast, right? Things that human mind can do in a period of say a light year, right? Today's computer, it takes only 1 second. 1 second. So that is the advantage that we get, right? So therefore, for interaction, we use a language. We call them high-level low computer languages. Python is a high-level object-oriented computer language, right? So therefore, what we do is we cannot take the real world objects into the computer. For example, say, if I want to, study or do something with this mango tree, can I take this mango tree and put in the computer? No. What we do is we obtain the essential properties of the sun and behaviors, essential details we call them. These details are modeled. We make a model with these details and then we take it as a software model. Software model consists of data and instructions. Data here, what is data regarding the mango tree? The tree type is mango, right? Which is data. Okay, tree type. So they are tall trees, another data, right? They bear fruits, another data, right? So if you want to study or if you want to do something with this, if you want to interact with the mango tree, we have to take that essential details. These details will consist of data, which you call states, data or states, and the behaviors, right? For any object, there's an behavior and there are data regarding that object, right? So therefore, object you have to visualize as something, which has two main things first, right? Data and the behaviors. Data we call states. Behaviors are the actions, right? That they do, actions that they do or actions that we can do on them. They are the behaviors, right? So therefore, because you can't take these real world objects into the computer, we make a model, software model, and then we take that model into the computer's memory. That is the way that we use the computer. So now the whole behaviors and properties or the data regarding the mango tree is available as a software model in my computer. Right now, I can start, doing various interaction with this model. Okay. So therefore, when you interact with the computer, we use, say, now we are going to use Python now, right? So for each object, Python, there's a type. This is how the Python sees the world, right? Now take a mother to understand this son, right? Take a mother having, say, 5 children, right? Mother's love is is equal for all the children, right? Mother does not, treat the elder one or the younger one, better than the others, right? That is uniform. That is uniform. So therefore, mother will see all the children, all these objects or children as her own, as her own. Excuse me. As her own children. So that is called a type. That is called a type, right? So the Python gives, or Python uses a type to classify these objects in the real world. To classify these objects in the real world, right? Real world. Okay. Type tells the compiler and the interpreter. Okay, now we know real world things have to be translated into the computer's language, right? We discussed about the translator can be a compiler taking everything and translating, or an interpreter, okay, translating step by step and running. How the object should be used and treated, right? The types is important for us. Computer should know how should I understand about this real world objects. It's new to me. It's new to me. Okay. It is just like you bring a wild animal to a house. Now you should know his behavior, and the data regarding this one is an object, right? Then only you can read. You can read this one, right? So therefore type. For example, take an object called animal. Animal is a type now, right? So to treat it, at least to feed it, feed this animal, we should know what he eats, what he drinks, right? And what he does, whether he sleeps or not, all these things we should know. So therefore, the type will tell you all these things. The type will tell you a very good, gives you a very good introduction about the object, so that we can treat it as a known subject. The unknown subject, from the type we know, it becomes a known subject. So therefore, Python has classified everything in the real world to something called a type. It has given types. We'll see later on what types are available also. Right? Now take type also reveals the operations that can be done on objects. Right? For example, if it is a rubber ball, you can press it. Right? If it is a leather ball, you can't press it. Okay. So the type shows, it reveals, it shows you what operation that can be done on this object and what behavior will be expected from the object. Okay, my students, did you get my points? Type discloses how objects are stored in the memory. What do you mean by store? Now take two animals, cat and a dog, right? The dog will need a cage, right? And cat normally does not need a cage to live, right? So therefore, the type of object discloses how the storage requirement. It will give you an idea about storage requirements. Suppose we are going to isolate these two objects, cat and the dog, by putting them into cages. So therefore, for the cat, we make a small cage, for the dog, we make a very big cage, right? Big cage, right? So therefore, the type will disclose the storage or the space that you need here, right? So small objects will need small space, big objects will need big space in the computer as well. So therefore, that is the reason from the Python language's point of view, when you look at the real world, Python sees them as, right? Python categorize them into different types. So therefore, and allocates classes, put into classes these objects. So for every object that Python handles in the real world, there's a type. We will be learning very soon, how we use Python to find the type of whatever the thing, right? Okay. Now look at this example, this picture. The image can't be displayed. Your computer may not have enough memory to. Okay. There was an object. I think I got a small message when opening this one, right? That may be the reason I'm not getting this one, but I will upload the correct object with you. Right? Here, the picture was here. I put a picture here, ball and a batsman. Right? So, ball is an object. Now imagine there's a batsman with a ball. Right? So, ball is an object, batsman is an object, bat is an object in the picture there, here, if you had the picture. Right? So that is the data regarding this person, data regarding that one. What is the behavior? Behavior means the operation. Batsman can hit the ball. Behavior is, right, when you hit the ball, the ball is thrown away. That is a behavior there, right? So therefore you will see in all type of objects you will find these two things. Basically, it's not two things. There are three things that are needed to describe an object. Let us take the first two, the major two. One is the data regarding the object. The next one is the operations associated with the with this one. So those are the two things. Operations means the behavior. So first one we call the state data or the states. Second one we call the behavior, state and behavior. So therefore, what is an object? If someone asks, object is something which possesses. Object is something which possesses states and behaviors. That is the answer, simple answer for an object, right? So objects can be tangible or physical objects. Objects can be virtual objects, right? Virtual objects are the models of the physical objects. This is the summary that I did. Okay. Now, for example, third one is the storage or the space you needed for an object, right? Space that you needed. Remember, if you can remember your science, I don't know these days, what science the teachers teach you in the school. But truly, a good teacher should, first start your science with the matter. Everything in the universe consists of matter. And today, recently, scientists found there's dark matter also. Dark matters are not, they are invisible, right? Still they exist. So therefore, matter, we have to start the science with the matter. Likewise, right? You have to start the programming with the objects, object-oriented programming with the objects. Okay, right. So therefore, anything in the world, right? It has its characteristics we call data or the states. Then they have the behaviors. You can't separate them, and also it needs it needs space to live, right? It occupies a space, occupies a space, right? It depends. Space also depends, right? Now say for certain objects, we have lot of attributes or data. For some objects, we have little, right? For some objects, we have they do lot of operations. For some objects, we don't do lot of operations. It varies from object to object. Take this one, money. Suppose if you are a poor person, you need a small safe to store. But if it is a very if you are very rich person, then this is not enough. No, you need a very big safe to store the money. Likewise, the computer, in the computer also, this is the memory. This is the memory you need. For some objects, we need big memory. For some objects, we need small memory. Okay, so therefore, how Python sees the world is Python sees everything in the world as of having a type, right? Type. Now let me go to the next page. Right. How Python sees the world? How does Python see the world? Right. This is the Python language, right? How he sees the world. He will see any object in the world, right, is divided into 9 types. 9 types. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, correct. 9 types, right? So if someone goes for 10, Python cannot handle it, right? So Python has divided all the objects in the world into 9 types, 9 categories, 9 types. Is it clear? Is it clear? Now can you see I have put different colors? 1, 2, 3. These 3 are grouped now. Int means integer, whole numbers. Float means floating point numbers. They are not whole numbers. Complex numbers. Those who have done advanced level mathematics, they may have come across complex numbers. A combination of a real number and an imaginary number we call a complex number, right? I will explain these things, don't worry others, right? So they are numbers. These 3 are numbers, numeric types, right? So we have numeric things, countable things in the world, numeric things, on which we can do calculations. That is one category. So Python categorizes that into 3. Then Python sees non-numeric things. From here to here are the non-numeric things. In non-numeric things, Python groups the types into something called str. Str is a string. A string is a collection of characters. For now, before I explain more about that one, you can imagine. Okay, we call them strings, right? Strings in the real world, you know what a string no? A string may consist of say a necklace. Take a necklace, consist of pebbles. Pebbles that are put inside the thread, small thread, and there are 2 knots at the end, which is a string. In computing also, it's a similar thing that we are talking about. It's a collection of characters. Characters are letters, maybe digits, maybe special symbols, maybe everything we call which are not participating in calculations, we call them strings, right? So therefore, strings are non-numeric. Although they consist of sometimes digits, we don't use them in arithmetic. For example, say you have an account number, or you may have a telephone number. No, you are not going to multiply the telephone number by 2. No, it's not numeric. Although it appears numeric, right? It is, in actual practice, it is non-numeric, which we call string. So take your telephone number and put a delimiter. Delimiter means starting position, you put a mark, you mark the starting position, you mark the end position of your telephone number. Now we call it a string, right? And we are not going to multiply. We are not going to add it, non-numeric, right? See Python, how Python, how Python is smart enough to categorize the real world things. So we have numeric things, they can participate in calculations. Then we have non-numeric things, they cannot participate in calculations, and we say they are still data. Okay, they are valuable for us. People's names, right? They are not participating in calculations, but we need names. Everything in the universe has a name, right? So str means non-numeric things. Anything which belongs to non-numeric can be treated as a str type. Then we have bool. Bool means in the real world we have, when you ask a question, short question, we say yes or no. It's a logic actually. It's a logic. So if I ask whether did you take the lunch? What is the answer? Either yes or no. Right? You can't give any other answer, no? The valid answer. There are you have to have only one valid answer out of 2. Which we call Boolean or logical category or logical type. So that anything which belongs to the logic will put into this category, right? Into this category. Anything which belongs to calculations, we put into one of these categories, right? Anything that belongs to the string or the non-numeric, we put into this one, this category. Okay. Then there are groups of things. There are groups already there. Take a coconut cluster. There are so many coconuts in a cluster, right? But they exist as a unit. They exist as a unit. We use a train as a joint structure of compartments, right? It is a unit. It has maybe 1,000, say 400, that sort of compartments. Still, when you join, we call it a train with an engine. We call it a train. So they represent group of objects, right? Group of objects, right? For example, take a list of names. When you say list of names, it consists of not a single name, it consists of many names, right? To represent that one, we have a type in Python called list, list, right? And here also another group which is called tuple, right? Their behaviors are a bit different. Their collections are different. They collect, different things in here. Another one is the dictionary. Another type. Dictionary means normally, say in a dictionary, what do you get? In a normal dictionary, what do you get? You get a word and the meaning. You get a word and the meaning, right? So if you separate word and the meaning and put it, somewhere else, it won't be a dictionary. So dictionary is a combination of combined effect of words and meanings, right? So Python is also having, because so what is the point of having a needle if you don't have a thread? Needle and a thread, they go together. So there are things in which go together, right? To represent those, we have another category called dict. We have another category called dict, right? So it represents a group of objects, but their behaviors and data are different. right? Dict, dict, okay. For example, another example is say there are 7 days in a week, right? So therefore, if you take a name called week, you can combine with 7. Why? They are related. A week does not contain say 5 days or 8 days, right? In a month you have 12 months. In an year you have 12 months, so they can't be separated, right? So therefore, to represent these things, we use the group structure called dict. So that is the third one. The fourth one is a set. Set is a very special structure. Maybe by now some of you have learned the set theory also. Set theory in mathematics. It's in the O level. I have seen maybe in the grade 8 also sets. Okay. So to cater for that sort of data, Python uses another type. This is also a group. So therefore, the blue ones represent what? Groups of having these type names, and others are these three are numeric things. This is non-numeric, this is logic. So this is how you count this up to 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this is how Python sees the world, right? If Python is alive, if our computer language is alive, he will see there are only these 9 things in the world. Okay, you have to understand that, right? Okay. Now take these 4 categories: integer category, float category, complex category, and the bool category.
බැලුවේවත් නෑ මොකද වෙන්නේ කියලා. මම ආගත්තද? මොනවද කිව්වේ? ප්‍රෝග්‍රෑමින් ඕනේ වර ඉස්සරහට දාන්න ඕනේ. ප්‍රෝග්‍රෑම් එක ටයිප් එකක් ඉස්සරහට ගන්න ඕනේ. ඕන එකට ගහලා ගන්න. බලන්න ඕනේ වලට IT කරලා තියෙන්නේ. ඕක මම ඕනේ වලට කරලා නෑ. මයික් එක ඕන් කරලා
I told you at the beginning not to talk, right? Those who don't so those who want to spoil the lesson, I will take strict actions, right? They can stay at home without disturbing the students who want to learn. I told you at the beginning, right? I will not these students, and one day you have to people who are disturbing, right? You spoil the whole thing. Python කරලා තියෙනවා නම් කලින් ඉගෙනගෙන තියෙනවා නම් මෙහෙ එන්න ඕනේ නැහැ නේ ඔයගොල්ලෝ. කරලා නැති හින්දා නෙන්නේ හින්දා ඉගෙන ගන්න. ඔන්න මම සිංහලෙන් කිව්වා.